Picture this: the sun's down, the wolves are howling, and your car abruptly decides to conk out somewhere between nowhere and civilization. Before the 80s, the only option would have been to hitch a ride or start hiking. Luckily, things began to change with the advent of cellular networks. Now, as long as there's a signal available, you're just a quick call away from getting out of trouble. But soon, thanks to a chain of technological triggers, we might even be avoiding the breakdown in the first place. Mobile signals tend to be taken for granted nowadays, but the extensive 3G and 4G cellular networks are byproducts of decades of technological progress. Here we have a chicken and egg situation. Sort of. What came first, cellular networks or mobile phones? The creation and commercialization of portable communication devices compelled the establishment of cell towers designed to transfer data. Next, as networks changed from analog to digital and eventually tapped into the internet, mobiles evolved into smartphones designed for increasingly efficient lifestyles. Introduced in 1998, 3G popularized the idea of cellular networks, then 4G in 2009, with the previous eras really only ever earning retrospective praise. Unsurprisingly, 5G looks set to blow all of its ancestors out of the water, but it's never too early to start planning for the future, with 6G tipped to launch at the earliest in 2030. It seems a long way off, but various countries and companies are already looking into it. At its simplest, a network is a group of interconnected systems designed to communicate with each other. The internet is one huge network, but a more modest example is an everyday office, which tends to link individual computer terminals to a central hub that receives and transmits data. Cellular networks are based on the same principles, although there are certain differences. Rather than one central hub, operators divide the network into thousands of smaller cells, with a base station at the center. A mobile device's signal is determined by the nearest station. True, 2 and 3G brought the internet to mobile devices, but it was 4G that made reliable on-the-go browsing viable. The likes of Snapchat and other live outdoor vlogs are only possible because modern networks can handle the demand. Now, with things like watches, security cameras, and self-driving cars also hopping online, 5G aims for an even more reliable, faster, and safer experience. In fact, it marks a major turning point, as 5G proposes to alter the basic method of data transmission. Rather than a centralized base station communicating to devices in the wider area, going forward 5G relies on smaller antennas to spin its web, and much more of them. It's a system built on the establishment of multiple smaller cells. In terms of how successful 5 and 6G will or won't be, much rests on the frequencies they'll operate at. Networks access a specific frequency to transmit data, with a higher range allowing for a faster signal. While 4G operates somewhere in the range of 2 to 8 GHz, 5G should be able to reach frequencies upwards of 30 GHz. It's the difference between crawling through a heavily congested highway or whizzing by in a bullet train. So 4G set the standard for a fully data-driven infrastructure, and 5G will increase it. But 6G has an arguably even more vital role to play. In an age when even a 1 millisecond delay could be the difference between a fatal car accident and a timely stop, data transfer must be instantaneous. 5G offers less delay than ever before, but the technology still relies heavily on radio signals, and a piece of information still has to pass through thousands of terminals before arriving at its destination. In the best case scenario, it's a tiny amount of loading time. In the worst case, it's prolonged buffering, which brings about some kind of disaster. Cellular networks have way more than just tablets and smartphones to worry about now. The Internet of Things is an ever-growing technological ideal that aims to connect everything in the world to the internet. It's not hyperbole either. By 2030, when 6G rolls out, it's thought that there will be up to 500 billion IoT devices, all linked through a wireless network. Of course, it'll be 5G that paves the way for this, as new tech should prompt the installation of wireless sensors in everything from factories to robots to airplanes. While simply dismissing 5G as some kind of stepping stone to 6G isn't entirely fair, as we can expect it to trigger countless tech innovations between then and now, the two are clearly linked. The eventual shift between them will likely stem from an increasing AI presence. Researchers believe artificial intelligence will play a defining role in an IoT-driven world, with it determining the most efficient way to transfer data. For some, an ideal system is one that's free from human intervention at all, and that's what 6G could become. In terms of speed, 6G looks set for a terabit per second. That's an entire 4K movie in the time it takes to hit the play button. By comparison, 4G averages at a miserly 20 megabits per second, and 5G promises 10 to 20 gigabits. A massive jump, but just 2% of what 6G will bring to the table. With 5G, it's milliseconds to transport data from the source to its destination, but with 6G, it's down to microseconds. But what about coverage? Few things in this world are more frustrating than entering a building and immediately losing signal, and 5G could actually struggle here, at least at first. As radio waves grow progressively weaker as the frequency increases, and 5G still relies on radio waves, it could have trouble penetrating the walls of buildings and homes that even the simpler 4G system could breach. But there is a relatively straightforward answer to the problem. If the signal fails to reach the finishing line, then bring the endpoint closer to the start. 5G will truly start to shine once millions of cells and antennas are installed to make up for the poor coverage. By the time 6G rolls around, with frequencies expected to tip 252 GHz, there should already be a usable infrastructure in place that only needs to be improved. Love it or hate it, higher wireless speeds will inevitably demand the installation of mobile base stations inside individual buildings. In many ways, 6G could feel like a step backward, seeing as we'll suddenly be seeing so much more of the physical structures and devices that make the internet tick. But it's all driven by the need for faster, stronger, and more reliable connections. With so many things wirelessly connected today and in the future, the aim is to make being on the internet, or engaging in any wireless connection, feel seamless. In exchange for installing an indoor antenna, users can look forward to a more instantaneous experience. At the moment, 6G is a distant dream, but research has started and the cogs are whirring. An operational 6th-generation cellular system means trillions of devices all knitted together. According to early predictions, it means a fully automated data transport system. Specifically, it'll allow for more clothes designed to monitor the wearer's health, greatly improved augmented and virtual reality adventures, roads that can warn before potholes start forming, restaurants that can prepare your meal to serve at whatever time your self-driving car calculates that you'll arrive, and that self-driving car should never unexpectedly break down. Everything talks to each other without us needing to press the button. It's the future, and it'll one day be the reality.